This video is part of the series about peak detection algorithm called ApexTrack. Here, we'll discuss how ApexTrack locates a baseline for isolated peaks or in case of peak clusters. So in case of isolated peaks, locating baseline is very simple. We simply find where the peak starts and ends and put two baseline anchors there. Then we draw a straight line in between, and that's our baseline. What about the space between peaks? We simply connect the end of the previous peak with the start of the next peak. So in the end, the baseline is just a series of straight lines that covers the whole chromatogram. You may have noticed that even though these are actually two merged peaks, for baseline detection we treat them as one peak cluster. Here's an interesting example of clusters. Two similar situations, but in one case the baseline is determined correctly, while in the other case, well, you can see this embarrassment yourself. So what's happening here? You may not see this well, but these peaks don't actually touch, and therefore they don't form a cluster. So the baseline for each of the peaks is drawn separately. If we look at the integration method, the liftoff and touchdown parameters are higher for this chromatogram. As a result, the peak's boundaries are not as wide as on the chromatogram above. Once we lower the thresholds, the peaks just got a bit wider, which made them meet. So now they form a cluster and the baseline is drawn correctly. So whether the baseline is located correctly or not can depend on the parameters which seem to be unrelated to baselines. Another problem that you may have noticed is this area. Oftentimes, the baseline drift is a result of gradient illusion, and therefore it manifests itself as a straight line. But when it's curved, and we don't want to consider this a peak, we will have such artifacts. And the only way to fix this is by manual baseline correction. Thanks for watching, we'll see you in the next video.